Hello, everyone. Yeah, many of you know, those who are into machine learning things, many of you know about k-means clustering. What exactly is k-means clustering is it's one of the machine learning algorithm. Of course, again, machine learning algorithms are categorized into broadly into two, unsupervised and supervised. K-means is one such unsupervised machine learning algorithm. What exactly it tries to, what exactly, I'll just brief the k-means algorithm. What exactly it does is, it is used to group similar data points into a predefined number of clusters. And usually those number of clusters are denoted by k, hence it is called k-means. Okay. So if there are points within the same cluster, points within the same cluster are mostly similar. Points within different clusters are mostly different. How exactly this clustering is being done is using the sum of squared distances between the data points and their cluster centers. Okay, and then those cluster centers are usually called the centroids. Okay, yeah, many of you are aware of this. Also, if you want me to briefly give a description of what the k-means is, I will just put it like a flow chart. What that is. First, we will choose k. That means what? We will decide how many clusters we want. Okay, given set of data points, how many clusters you want, you will decide. And then we will initialize the centroids for the clusters. Initialize centroids. Initialize the centroids. Once we initialize the centroids, next we'll assign points. What is being done? Assign points. Usually to the nearest centroid, the points nearest to each centroid are assigned to that. Okay. Assign points to nearest centroid. Of course, this nearest to farthest are calculated using Euclidean distance to the nearest centroid. Euclidean distance plays a major role. Okay. Now, of course, initially we choose the centroids. The centroids get upgraded. New centroids are being calculated by taking the mean of all the points that's assigned to each cluster. Okay. Upgrading the centroids is being done in this algorithm. How it is being done? By taking the mean of all the points. It's been done. Okay, upgrade or update. Okay, and this process is repeated. Reassign the points, update the centroids until centroids no longer change. This process is repeated. This is what is k-means clustering, guys, about which all of us are aware. Now quantum k-means is a mimic or of course a better version similar to the k-means clustering. Okay. Now, of course, the quantum implementation of k-means clustering can be achieved using Euclidean distance only, Euclidean distance calculation only. But along with Euclidean distance calculation, we go with Grover's search algorithm. One of the best searching algorithm is Grover's search algorithm in quantum. Okay. So I will write here Euclidean distance, that strategy or that weapon or tool that we used in k-means is as well used in quantum k-means along with Grover's search. Grover's search. I made a video on Grover's search as well. If you want to know what it is, kindly go through it. Euclidean distance calculation routine along with Grover's search algorithm routine is used for implementation of quantum or quantum implementation of k-means. Also can be said quantum implementation. Suppose if I want to implement it on a quantum computer, then these two things are combined and used. Quantum implementation of k-means clustering or k-means algorithm, whatever. Okay, the steps are almost the same, with the individual steps being carried out by quantum routines rather than the classical ones. I will write here steps of quantum k-means is the same as classical k-means, with individual steps being carried out on quantum routines, Yeah, those who have seen my video on quantum linear regression, it is similar to linear regression only. Two major changes will be there. First thing is the normal data that's been given is converted to quantum states, and remaining almost similar things are being done. System of equations are being formulated. After that, to evaluate or to find the unknown, HHL algorithm, which is a tool again in quantum, is being used to find the unknown, to assess the value of theta. Okay, similarly here, k-means clustering only steps are similar to k-means clustering only, but only thing is those steps are carried out on quantum routine instead of classical routine. Quantum routine rather than on classical routine. Okay, yeah. Now, as mentioned about k-means, first what? Initialization. Initialize the k cluster centroids. K cluster centroids. I'll call them here to be mu1, mu2, and so on, mu k. They belong to Rn space, using a heuristic similar to that in classical version of k-means. Okay. For instance, one can randomly choose k data points as the initial clusters. K data points as the initial clusters. Okay, yeah. Coming to the steps or the working rule. First step, for each data point xi belonging to R power n. Of course, when I say this, you should remember the quantum version again, represented by its magnitude, xi, the vector xi, stored classically, and by its unit norm, get xi, stored as a quantum state. Get xi, as all of us know, those who are aware of quantum, stored as a quantum state. For this get xi, we compute the distance using quantum Euclidean distance. Of course, I made a small video on quantum Euclidean distance as well. Kindly look into it. We compute quantum Euclidean distance. Okay. I will write here just how to calculate quantum Euclidean distance. Dij, this is equal to norm xi minus mu j, the centroid. This is equal to 4z p ket 0, probability of ket 0 minus 0.5. Okay. Now, calculation routine with each of the K cluster centroids. We compute the quantum Euclidean distance calculation. We compute quantum Euclidean distance routine with each of the K clusters, each of the K cluster centroids. Okay. Now, what is xi is, of course, I know. What is j is? J belongs to the number of clusters that I have distributed. Okay. Each cluster will have a centroid, hence K clusters and hence K centroids. Okay. Next, what we will do? Euclidean distance and then Grover's search, right? The next step would be Grover's search algorithm. Again, it's a powerful algorithm, quantum algorithm it is. Okay. Yeah. Now, what we use Grover's search algorithm. This algorithm is used to assign each data point, xi to one of the K clusters, Now, the job for Grover's search algorithm is it should be able to take the distance Dij and assign the correct cluster Ci. Okay. What is the job of Grover's search? Grover's search algorithm should take the distance Dij and assign the correct cluster Cij to the quantum state under consideration. Okay. Yeah. Now, how that is done, just see here. Ci is equal to argmin. Of course, this is repeated j times xi minus uj whole squared. Ci belongs to 1, 2 and so on k. Okay. Yeah. Once each of the data point xi is assigned to its cluster Ci, then the mean or the center of each cluster is computed. Okay. Once Grover search does its job, then what happens? I'll write here. Once Grover search algorithm, of course, I'll write it in bracket. Each of the data point xi is assigned to its cluster Ci, belonging to 1, 2, k, the mean or centroid of each cluster. Again, because I have to change the centroid, na, I have to upgrade the centroid or update the centroid. Na. The mean or centroid, as per the steps in k-means, the mean or centroid of each cluster is computed as follows. How? I will just give the procedure. Uj is equal to 1 by n, 1 by nj, summation ci is equal to j xi. Okay, uj is equal to 1 by nj, summation ci is equal to summation of all those. The new centroids are being, or the new mean is being calculated. You can understand that is like exactly like our mean, not the weighted mean, the normal mean. What exactly is nj is the number of data points that belongs to a cluster. I will make a mention. The new thing is here nj. Nj is the number of data points. How many data points are there in each cluster? Divided by that only, na? Denotes the number of data points that belong to a cluster. That belong to a cluster. Okay. Basically it is this. That's it. The 3-step process. Of course, if you ask me, this is it. No. Repeat this procedure until it converges. Okay. Repeat these steps until they converge. Okay. The algorithm, when does it converge? When the data points stop changing the cluster over subsequent iterations. When we check this 2 subsequent iterations, the clusters, the data points, what they happen? Some data points, once they are in one cluster, then in the next iteration, they change to another cluster. So once this stops and all the clusters are properly formed, I will just stop the iteration process. Or this is called as a convergence. Okay, convergence of the procedure. I will just write the last step. Not the last step, but the end of the procedure. The algorithm converges when data points stop changing their clusters. Data points stop changing clusters over subsequent iterations. Okay. Now, if you ask me about what's the order of convergence, when I'm saying convergence, I should make a mention, right? For the k-means, as we know, the order of convergence is order of big O mnk. For each iteration. For each iteration, it is like that. Where, of course, we know what is nk, right? Now, the distance computational complexity for each data point to a cluster is of order n, where n is the number of features of the data point. Since there are k clusters for each data point, the complexity is order of nk. Since each of the m data points would have complexity order of nk, the overall complexity would be mnk. Okay. Now, what would I tell about the order of convergence of the quantum, if you ask? Now, the quantum Euclidean distance computation is there, na? Quantum Euclidean distance from a cluster, its order is order log capital N. Of course, in the explanation also, I just gave a justification for quantum Euclidean distance. Kindly check. So, overall complexity would be m log capital NK. or the overall order for the quantum k-means would be m log nk. Of course, here one thing I can mention is that if Grover's algorithm is properly trained, properly if it is being given inputs, then the speed can be increased much, much better for the k-means clustering. Okay, this is of course there is one more in k-means clustering using cosine distance, guys. I'll just stop with this for this video. Then if needed, we'll talk about k-means clustering with cosine distance as well. Okay, we should as well look at one problem on k-means clustering in the coming video. Okay, yeah, thank you for your patient listening.